Bhavya, good evening, beta. Shall we start the class, please? Okay, Tanisha, good morning, good evening, good afternoon. Everyone, good afternoon. Let's start the session, beta. Now look here. Today we are going to start a new chapter, and that new chapter is chemistry. And in that chemistry, what we are going to study is matter around us pure. Okay. So in this part, we are going to first study about matter. Now, beta, we must understand that if somebody will be asking you, first question I'm asking from all of you. We studied in the previous chapter. What and all we have studied in the previous chapter? We were discussing about, yes, Bhavya is present. After Bhavya, it's Tanisha is present and Arunisha is present. Three children are present. I got their attendance. For you only, I started chemistry. You told now. He told chemistry class start, so I started chemistry. Now listen, Peter. So I started chemistry part. Please kindly listen nicely. So we need to understand about matter. Matter already we know that anything which occupies space, has mass, and which can be felt by senses will be considered as matter. Okay, matter. Okay. Now we are going to understand कि whatever matter is present around us, are they pure or not? What is the meaning of pure here? So how can we classify pure? What is the meaning of pure and what we understood about the term pure? Tanisha, can you explain what does purity in matter means? Okay. What does purity in matter means? Huh? See, purity in matter means does not have any mixtures. I don't think so. Let's see. I haven't got any answer. Does not have any mixture is purity. Then I don't think so. It is like that. No. Think very nicely. Now I am going to explain this one. Come on, children. Understand this part. So we will study this chapter. What and all things? The matter which is made up of atoms. Matter is made up of atoms. And after that, what we are going to study around this is of two types. What are the two types? One is pure. Okay, Tanisha has sent the answer. Pure substances are material that have only one type of particles. Very good. That have only one type of particle. She has two material which is exactly having one type of is exactly made with one type of particle. This is the statement given by Tanisha. Very good. Now, pure substances are elements and compounds as they contain only one kind of particle. Very good. So, what is exactly pure substance? So, first, matter is classified as how many types? Two types. What is matter classification? We can classify matter as two types. One can be classified as pure, another one can be classified as mixture. Pure and mixture. Very good, well done. The next part. The next part is कि pure substances are elements and compounds as they contain only one kind of particles. So we can be talking about pure substances. Now pure substance can either be element or compound. What is element and compound we will understand, but pure substances can either be element or compound. Can either be element or compound. Now next, homogeneous mixture of two substances form solution. Now again we are going to talk about mixtures. So mixture means what? When two or more pure substances are mixing together, it is exactly making what? Mixture. It is considered as what? Mixture. So one simple example I am giving you. One simple example. Auntie, screen is not visible. Now is the screen visible? So the matter which is made up of atoms will be exactly classified as how many types? It will be classified into two types. What are the two types? Pure substance and mixture. Pure substance and mixture. It will be classified into two types. What are the two types? Pure substances and mixture. So pure substances are can be exactly coming as from where? Element and compound. So like we will be taking about hydrogen gas. Understood? So when hydrogen gas group we will see, it will be considered as pure substance. Understood now? Now when hydrogen gas at different types are going to react with each other, when they will mix together, it will be called as mixture. Like our air. Air is exactly mixture of many other different type of gases. So air is a mixture. Understood or not? Because it is exactly constituting of different type of gases in it. Understood or not? So our air in which we are breathing is mixture. Nitrogen gas is there, carbon dioxide gas is there, hydrogen gas is there. Correct now? Carbon monoxide gas is there. The different type of gases will be present in it. So it will be considered as what, beta? Mixture. It will be considered as mixture. Now next, homogeneous mixture is of two substances from solution. Homogeneous mixture of two substances is forming what? Solution. So now you must understand that after that mixture can be of two types. What are the two type of mixture? One is homogeneous mixture, second one is heterogeneous mixture. So mixture can be classified into two types, homogeneous and heterogeneous. Homogeneous and heterogeneous. So after that we can classify mixture as two types, homogeneous and heterogeneous mixture. Okay. Now, if the size of particle is big enough to be seen with naked eyes, it will be exactly forming suspension. It will be forming what, beta? Suspension. Suspension means what? Suspension means the particle will be suspended. The particle will be suspended. Understood not? So they will be exactly suspended, and after some time, what they will do? They will settle down. Got it? So in simple word, if somebody will ask you, you say that sand particles are there, auntie. Their sizes are very, very big. So if I am adding sand particles in water, I am seeing that the sand particles are settling down. The sand particles doing what? They are settling down. So they are what? They are actually mixture. What they are? Mixture, because they will be different, made with different type of sand particle mixed together. Correct or not? And when they will be exactly mixed, after some time what they are happening, what they are doing, they are actually settling down. I hope you might have understood. Now, if the size of the particle is big enough to be seen with naked eyes, then suspension is formed. So that means if the particle will be seen from the naked eyes, what it is making? Suspension, which will get suspended. Suspension means it will get suspended. It will get settled down. That's why it is called as what, beta? Suspension. Or it is called as suspension. Now, if the particle size is between solution and suspension. Now, first is solution. Solution where both the solute and solvent will mix together nicely. Like I am adding salt in water. So salt is solute because salt is less amount and water is solvent. And solute and solvent mixed together will make solution. That type of solution is homogeneous. I'll explain everything. That type of solution is considered as what, beta? Homogeneous. Understood? So homogeneous solution will be what? Where it will be nicely mixed and you will not be able to differentiate that it's pure water or it's mixed with something. Correct now? So if I will add a pinch of salt in water, you will not be able to find now where this salt is going. Between the water molecules, some gaps are there. So these what we call salt particle will occupy that spaces. This salt of particles will be occupying that spaces. Understood or not? The salt particle will be occupying some spaces. I hope you might have understood this one. Now we will go for the next one. So separation of mixture can be done by filtration. Now next filtration is there. So when we can mix, we can separate out also. When we can mix, we can separate out also. And separation can be done by filtration, like centrifugation, chromatography, and distillation. These are the process of separating the mixture. Understood? So these are the content we are going to study in this chapter. First content what we are going to study, pure substance and mixture. Then we will understand pure substances made with elements and compounds. Next we are going to understand about homogeneous and heterogeneous mixture. Homogeneous means solution making, correct or not? Heterogeneous collide and suspension will be there. Collide and suspension will be there. After that we will study how to separate mixtures. How to separate mixtures. After that we are going to talk about chemical change and physical change. So these are the topics we are going to study in this chapter. So I have given a small introduction of the chapter. Now are we going to start the chapter? Yes, we are going to start the chapter. So now first part we are going to study. So classification. So we are going to talk about matter. Matter is divided into how many types, beta? Two types. Pure substances and mixtures. Pure substances and mixtures. It will be classified into how many types? Two types. What are the two types? Pure substance, Bhavya. What are the two types? Kanisha, Bhavya. Where is Shanvi? Understood, it will be of two types. Mixture. What it is exactly? Mixture and pure substances. Now, pure substances will be classified as element and compound. Now, when we talk about element itself will be divided into three categories. What are the three categories in which the elements are divided into? Metals, non-metals and metalloids. Understood? Metals will be S block, D block. Now metals will be what? Pure. Okay. Metals will be S block and D block. Metals will be what? S block and D block. And non-metals will be what, beta? Yeah. Metals will be S block and D block. Means metals we can talk about sodium is metal, magnesium is metal. Understand or not? Non-metals like gases. Most of the non-metals are gases. So we will be talking about non-metals. In non-metals, what we are going to talk about? Chair is not non-metal. That is plastic. We are going to understand about non-metal. Non-metal can be classified as carbon, nitrogen, understand or not? Then comes metalloids like silicon, arsenide. They are coming between metals and non-metals. Yes, Vita. So no, the things which are coming between metal and non-metal will be considered as metalloids. The one which is coming between metal and non-metal is considered as what? Metalloid. Chahil, Shanvi, ये क्या था? एनटीपीसी के एग्जाम मुझे कैसे पता है? मस्ती कर रहे हैं ना? लुक हियर. So metals, non-metals and metalloids. Got it? Metals, non-metals and metalloids. So we are going to talk about the mixture can be classified as two types. One is homogeneous mixture and second one is heterogeneous mixture. Heterogeneous mixture and homogeneous mixture. So mixture can be classified under two types, homogeneous and heterogeneous. Now first we will see the definition of substance. A kind of matter that cannot be separated into other kind of matter. Understood? A type of matter which cannot be separated into other kind of matter by any physical process is called substance. So quickly note down what is the meaning of substance. Substance means what? It is that type of matter which cannot be separated into other kind of matter by any physical means. Understood? So only it is considered as what, beta? It is considered as substance. So only it is considered as what? It is considered as substance. What we are calling it as substance. Okay? Come on, check this one out. For example, iron, sucrose, water, sodium chloride, etc. are substances. The composition of substance is same throughout even at the atomic or molecular level. So that means what? Okay, I'm moving. Note down, sorry. So like the definition of substance, what is actually substance means a kind of matter that cannot be separated into other kind of matter. We cannot separate it into other kind of matter. Like salt. I cannot convert salt into sugar. Is it possible to convert salt into sugar? Not at all possible. Can I convert sugar into tea leaves? No. So that means what? The substances which are exactly present, it cannot be converted into other one. So only it is called as what it is? Specifically it is substance. What name we are giving it? We are giving it a name called as substance. Come on, go for it. A kind of matter that cannot be separated into other kind of matter by any physical process is called a substance. By any physical process it is considered as what? Substance. Come on, go for it please. What we are calling it as? We are calling it as substance. Mhm. Then now we will go for the next one, beta. So the composition of the substance is the same. This is for fill in the blanks. This is for MCQ. Will the composition of substance change? No. The composition of substance will not change. So if I am going to talk about water molecules, okay, water molecules. So water molecule formula is what? H2O. In any case, we are not going to change this formula. Water means H2O. One day I will not say water is H2O. Next day I came and I told water is H2O2. Is this correct? The answer is absolutely wrong. This is not correct. H2O is the molecular formula of water. It will be constituting of two atoms of hydrogen and one atom of oxygen. So whenever somebody will be asking about water molecule, always you will be saying what? You will be saying H2O. What formula you are going to say? H2O. What is the formula? H2O. Some examples like sodium chloride. Sodium chloride is made with sodium and chlorine. Sodium chloride is made with what? Sodium and chlorine. Got it? Now we are going to talk about pure substances and types of pure substances. Okay, so a homogeneous material which contains particles of only one kind and have definite set of properties is called pure substances. So now beta, we are going to talk about pure substances. In pure substances part, what we are studying here is it is made with a homogeneous material which contains particles of only one kind and has a definite set of properties. Understood? It is considered as what beta? Pure substances. What it is considered as? Pure substances. Understood? So now what is exactly the meaning of pure substances? A homogeneous material. It is composition is same. It is not going to change. Which contains particles of only one kind. Same type of particles will be present inside. Understood? And has a definite set of properties. And its property will not change. Its property remains the same. And it is exactly what? And has a definite set of property. It is called as what beta? It is considered as pure substances. What it is considered as? Pure substances. I hope you might have understood. So pure substances we have understood. Now we are going to go for the next one, children. Get ready for it. So example, I am talking about elements right now. I told you in the periodic table, the elements will be classified as metal, non-metals and metalloids. What they are classified as? Metals, non-metals and metalloids. What they are classified as? Metals, non-metals and metalloids. So let's see. Iron, silver, oxygen, sulfur. What are they? They are actually iron, silver, oxygen, sulfur. So when iron and silver I am talking about, they are metals. And oxygen and sulfur is non-metals, are pure substances. So metal, non-metal, metalloid, all are considered as what? Pure substances. What they are considered as? Pure substances, because each one of them has only one kind of particles. What kind of particle? Each one of them will be having only one kind of particle. So only what they are considered as pure substances. Understood? So elements are pure substances. However, if a substance is composed of two or more different kind of particles, if it is exactly composed of two or more different type of particles and with a fixed proportion by weight, then also they will be exactly considered as pure substances. And how can we explain pure substances, Tanisha? Can you tell me about those type of pure substances which are not elements and they are compounds? Can you give me the examples of some of the compounds which are pure substances? Some of the compounds which are pure substances. Come on, go for it. Give the example. Some of the compounds, compounds which are pure substances. Example. Amrish, where is Kanishka Maharaj today? Exam. He is having exam. Come on, say. NaCl, absolutely correct. So Tanisha has given the answer NaCl. So if I'm talking about sodium chloride, so sodium chloride is made with two different type of elements. Understood? What is their composition? Okay, air is a mixture. Air is a mixture. Here only you did mistake. Air is a mixture. Air is a mixture. Air is a mixture. You can't take that. Pure substance I am talking about, compounds. Okay, compounds I am discussing about. Pure substances I want to know. Air is a mixture, remove air and then talk about some of the compounds only. I want to know about the compounds. So one example what you have given is NaCl. Sodium, one atom, chlorine, one atom. Joining together, they are making NaCl. They are compound and it is pure. Its composition is fixed. 1:1. What is the ratio? 1:1. Now, Tanisha, now Kavya, can you tell me another example of compound, please? Come on, go for it. Another example of compound, anyone? Come on, you can answer. Try it. Chahil, are you there in the group? Copper. I didn't understand what element. Okay, now you are getting it. Hmm? Lead nitrate. Okay. Now, okay, you are going correct only. You are going correct only. Come on, children. You are going correct only. Absolutely. So if somebody will be asking you about compounds, their fixed composition will be there. So now look at some other examples we can take. H2SO4, sulfuric acid. When we are talking about H2SO4, hydrogen atoms, how many atoms of hydrogen are there? 2. How many atoms of sulfur is there? 1. How many atoms of oxygen is there? 4. So their proportion, their ratio is fixed. 2:1:4. What is their by atomic composition I am talking about? 2:1:4. Not by weight, I am just talking about the atoms. So 2 atoms of hydrogen, 1 atom of sulfur and 4 atoms of oxygen. So they are exactly joining and this is exactly a compound. Very good. So answer sugar. Sugar, there will be two types, glucose and complex sugar. Two different type of sugars will be there. So the glucose part will be there, carbohydrate and complex sugar will be there. So that will be also considered as compound. Absolutely correct. Super. Fantabulous work. So now we will be talking about pure substance and mixtures we have discussed. Now we will be going for the next line. Next part we are going to talk about, so Lavoisier, a French chemist, on the basis of quantitative study, classified pure substance into elements and compounds. He showed that when we heat mercuric oxide, it changes into mercury and oxygen. So why beta? Because mercuric oxide is made with mercury and oxygen. Mercuric oxide is made with what? Mercury and oxygen. Okay, it is exactly made with what? Mercury and oxygen. So now, mercuric oxide is a compound because it decomposes into simpler substances. A compound can break into two compounds, two elements. Understood? A compound can break into two elements. A compound can break into element and element. Got it? So I can break a compound into two elements. I can break a compound into two compounds. I can break a compound into one element and one compound. So that means what? It will be exactly getting separated. So two simpler substances we can get from a compound. Now characteristics of pure substances. Come on, have some break and we are going to understand. Till now, now tell me, matter can be classified into how many types? Very good. Matter can be classified into how many types? Come on, children, start answering the question. Matter can be classified into two types. What are they? Pure and mixture. And we started discussing about pure. In pure, we have learned that dash and dash are pure substances, elements and compounds, and then we came to know that elements can be classified or categorized, converted. Element can be exactly of three types. What are the three types of elements? Metal, metal, non-metal and metalloid. Metal, non-metal and metalloid. I talked about one metal. What are the one metal one, what are the one non-metal and metal I talked about? Metal example what I have given. Now you are going to learn at least 20 atomic number element. Yes. Okay, answers are coming little late. Come on, go for it. Element we discussed. What and all are the element? Good afternoon, beta. Shreya. Good afternoon, beta. So element and compound. And then beta, what we have learned? We learned that elements can be classified as metal, non-metal and metalloids. So some examples we have also discussed. Hello beta. So now what examples we have discussed? We have discussed about the metals. In that metal part what we have discussed, we talked about sodium, we talked about hydrogen. Hydrogen is having an anomalous behavior that we will discuss afterwards. But we learned one thing, that metals can be of what you call the examples of metal. Some examples we have taken like sodium is a metal, magnesium, zinc, sulfur. Sulfur is what? Metal? No, very good. Sulfur is non-metal. Iron is metal. Absolutely correct, beta. So when we are, so shout out Shreya. Yes. Now, beta, when we were talking about non-metals, we talked about carbon, chlorine. These are exactly categorized as non-metal. And then metalloids. Germanium, gallium, these are exactly called as metalloids. Understood not? Understood. So they are categorized as metalloid, and metalloids are exactly consisting of the property between metals and non-metals. After that, what we studied? Come on, children. Tell me one another important point. Yeah, very good. So in that part, we were discussing about pure substances. In pure substances, we took the examples. Now I talked about that a compound is there. Compound will have fixed proportion by mass and weight, and the atomic composition is also fixed. We learned the definition of substance. Can you tell me the definition of substance now? What is the definition of substance we learned? Come on, say. A kind of matter that cannot be separated by any physical mean. A kind of matter that cannot be separated by any physical mean, that will be considered as what? Substances. And then we talked about substances. After understanding substances, we were discussing about pure substances. Correct now? So in pure substance, we have learned about elements. Correct? After that, what we are going to do is we are going to talk about characteristics of pure substances. Understood? So now one by one we are going to discuss about the characteristics of pure substances. So pure substance, first one. See, we are going to write everything in our finger and we are going to remember. So first is homogeneous. One word is homogeneous. Means it will not be of different, it will be of same. A pure substance is homogeneous in nature. Pure substance has definite set of properties. So properties, the pure substance will have definite set of properties. Pure substance will have definite set of properties. First one, homogeneous in nature. Second one, okay, and next is these properties are different from properties of other substances. So like if somebody will be asking you about oxygen and hydrogen, though they both are same, but they are different. Though they both are same, but they are different. Understood or not? Till here, everybody understood or not this part? Come on, check this one out. Now look here, beta. Is pure a pure substance is homogeneous in nature? A pure substance has a definite set of properties. It is having what, beta? Definite set of properties. It is having what? Definite set of properties. Second, these properties are different from properties of other substances. These properties are different from set of properties of other substances. What we were discussing at that time, we were discussing how its properties are different from other properties. Oxygen is a gas, hydrogen is a gas, but do oxygen and hydrogen same? They both are pure, but when they will combine together, they will be making water molecules. But they both are not same. They both are gases, but they both are different. They both are gases, but are they same? No. They both are different. Understood? Next, the composition of pure substance cannot be altered by physical means. We cannot change the composition. Understood? Not? So hydrogen atomic number we cannot change. Understood? It's fixed. But it carbon atomic number is fixed. We cannot change. Did you got my point? So the atomic number of pure substances or its composition cannot be changed. One example I have given you, carbon monoxide and carbon dioxide gas. Carbon monoxide and carbon dioxide gas. They both have carbon and oxygen. They both have, listen very carefully, they both have carbon and oxygen, but carbon monoxide is different and carbon dioxide is different. Carbon monoxide formula is carbon monoxide formula is CO. Carbon monoxide formula is CO. One carbon and one oxygen. But carbon dioxide formula is CO2. It is constituting one carbon atom and two oxygen atom. One carbon atom and two oxygen atom. So that is exactly the composition of carbon dioxide. This is the composition of what, beta? Carbon dioxide. One carbon and two oxygen atoms. I hope you might have understood. Now, first term, characteristics of pure substance. First characteristics, homogeneous in nature, absolute. Second characteristics, definite set of properties. Third one, it is different from, yes, the properties will be different from other substances. You cannot mix together. Understood? Then it cannot be altered by any physical means. Understood? So type of pure substances, elements and compound. Types of pure substances are what? Element and compound. Till here is it crystal clear? Pure characteristics of pure substances. One more time. Online children, type it fast. What are the characteristics? First word, homogeneous. Second word, definite set of properties. Third one, understood? Its properties will be different from other substances. And can we alter this property? No, we cannot alter the property. An example is pure substances can be divided into two types. What are they? Element and compound. What are they? Element and compound. So this is one of the most important part. Now we are going to go for the next one. Let's check about element and compound. The word element was introduced for the first time by Levy. An element is the simplest or basic form of pure substance which cannot be broken into anything simpler. An element cannot be broken into anything simpler. This statement was given by whom? This statement was given by Levy, and what they by any physical or chemical means. So any physical chemical means will not be able to break the element. The common example of elements are hydrogen, carbon, oxygen, nitrogen, sulfur, copper, silver and gold. These are exactly classified as elements. These are classified as elements. Now, how many elements are known till now? 115 elements are known. The universe is made mainly for two exactly. These are hydrogen and helium. So universe is made with what are the two different type of? What are they? The examples are Anvi, good evening. Today you're late Anvi. Now look at. So they are hydrogen. What is the composition? 92%. And helium is 7%. So again I am repeating. Hydrogen how much percentage? 92 percentage. Helium how much percentage? 7 percentage. And the rest of the element have a contribution of only 1% by mass. Rest will have contribution of how much? 1%. So mainly the two important elements in the universe is hydrogen and helium, and they will have what type of reaction? See, there are too many type of reactions are there, but in the universe we can be talking about nuclear reaction. Chemical reactions are there, nuclear reactions are there, but there in the universe what type of reactions are happening? Nuclear reaction, where the nucleus is breaking, understood, and they are making new element. Got it? So 92% is hydrogen and 7% is helium. So the two major element present which is exactly constituting the universe is hydrogen and helium. So how many we are knowing? 150. So most of them we are making. Most of them we are making. So some of the elements we are exactly radioactive elements are man-made elements also. Radioactive elements are man-made elements also. Come on, we can go for it. Man-made elements. Got it? So now look here, beta. The rest of the element have a contribution by only 1% by mass. Got it? So one out of known element, only about 92 have been found to be present in nature. The rest have been synthesized by scientists. Understood or not? So 92 naturally occurring are how many? Naturally occurring means we can be obtaining it from the nature. So what are they? Many are there. We are going to name it. But actually only few are made by scientists in lab. But 92 we are getting it in nature. Got it? So how was the class today chemistry? Is it crystal clear? Huh? Substance definition we learned. We learned about pure substance. Pure substances of how many types, beta? Two types: element and compound. Elements and compounds. Okay. So now contribution by mass and rest of that we have already studied. The man-made elements are known as synthetic elements. Natural elements are there and synthetic elements are there. So, but the natural elements are different from synthetic elements. That was also very, very important. Man-made elements are different from synthetic elements. Now, better will go. All living things, both plant and animal, are made from a few elements only. These are oxygen, carbon, hydrogen, nitrogen, calcium, along with some other elements. Understood? So, if somebody will be asking about oxygen, what is the composition of oxygen? 65%. What is the composition of carbon? 18%. So, all living things, both plant and animal, are made with few. What are they? Oxygen, carbon, hydrogen, nitrogen, calcium. Understood? And their composition is different. I hope you might have understood till here. Till here, everybody understood? Is it clear? If you are understanding, then please like the class better. Put a thumbs up. Thumbs up means like button you have to press. Okay. Yes, auntie understood. Bhavya understood. Arunisha understood. Tanisha, you will drink. I know. In between, you are going to drink water 100%. 100% water drinking capacity. Go drink water. No problem, beta. Thank you so much, beta. So drink water as fast as possible. Yes, auntie, understood. Tanisha. Okay, beta. Thank you so much. Okay, they went for water break. Till then, I can talk with my children. So, can you tell me some examples? Okay. Can you tell me? Thank you so much. Can you tell me some examples of metals? Give me some examples of metals, beta. Some examples of metals. A monkey. I said, put thumbs up in like button, not this one, so that our channel will not be kicked out by YouTube. Yes, lowest rated channel going to be out from YouTube. Bhavya, punch you. No, I'm just talking to them. Till you were going for break, I was talking to children. Shanvi is not here. Chahil is not here. Copper. Okay, in between you are giving answers also, some of the elements. Now we are going to talk about pure substances, aluminium. Okay, Arunisha is giving answers, aluminium. Then you have talked about silicon is element or not. Hey, one question I'm asking, that bulb is there, na? Bulb is having that thin filament, na? That is tungsten. Is it an element or a compound? Tungsten. Tungsten is element or compound. The thin filament which is exactly in the bulb now, you will be seeing some old bulb now. Nowadays the white colored bulbs are there, fluorescent bulbs are there. Now gold silver is absolutely correct. But I have asked you one question. Can you answer my question, please? Tungsten is element or compound? I. I'm asking something. You are delivering something. Compound. I. Many people are telling compound, but the correct answer it is element. Beta. It is element. Tungsten is element. Tungsten is element. Understood? Tungsten is what? Element. Tungsten, a monkey. Tungsten is what? Element. Just remember this. Tungsten is what? Element. Remember this part. Tungsten is exactly element. Got it? Correct only. Tungsten is element. Now metals, hey, get back. Break part is over. We discussed break is over. Okay. Now let us look at out of 92 elements, 92 are naturally occurring elements. Now rest other are synthetic. Rest other are synthetic. Am I? Huh? 23. Wow, super. Now very good. Out of 92 elements, nearly 70 elements belong to particular class known as metals. In metals, the atoms are very closely packed together and have a special type of bond known as metallic bond. Metals, what type of bond is there? Metals, what type of bond is there? Metallic bond. So metals are having metallic bond because very tight or close packings are there. So, and they are quite hard. So these are the properties of metals. These are what beta? Properties of metals. Understood? Now we are going to talk about physical properties of metal. What we are going to talk about? Physical properties of metal. First, solid at room temperature. First important property is metals are solid at room temperature. Metals are usually what? Solid at room temperature. But there are some exceptions also. The first exception is mercury, which is liquid at room temperature. Mercury is what? Liquid at room temperature. Water is metal. Super, very good. Is water element first? We are talking about element. No. Water is not element. First, water is, see, please understand that. First, in element are classified as metal, non-metals and metalloid. Right now, we are talking about metals of element. What we are talking about? Metals of element. In that, we are talking about what you call. In that, we are talking about those metals, all the metals, physical properties we are talking about. And in that, we came to know that usually all the metals are solid at room temperature. All the metals are solid at room temperature except mercury. Mercury is what, beta? Liquid at room temperature. Mercury is what? Liquid at room temperature. Mercury is what, beta? Liquid at room temperature. Mercury is liquid at room temperature. Now go for the next one, beta. If somebody will be asking you this point, okay. Next, shining surface. You know that metals are shining. The property is known as luster. So metal shining surface, what property it is having? Lustrous. So metals are having shining surface. Next property is conduction. They are good conductor of heat and electricity. Now my question is, why metals are good conductor of heat and electricity? Because they are, because see, metals are good conductor of heat and electricity because of presence of free ions. Understood? The free electrons present in them are making them responsible to allow current to pass through it. Understood? And they can also be good conductors of heat and electricity. Understood or not? So metals are good conductor of heat and first what we learned, they are hard except second point, luster means shining surface. Third point, conduction. They can conduct electricity. Fourth is hardness. Hardness means they are exactly hard, quite hard. Solid at room temperature and they are quite hard. So when we are talking about its hardness, sodium and potassium are only exceptions. Sodium and potassium both are metals. Understand this? Sodium and potassium. Sodium and potassium. Sodium and potassium, Na and K, both are metals. Sodium and potassium both are metals, but they are what? Soft. But rest other elements are, which elements? Metals are hard. Understood? They are solid at room temperature. Which metal is liquid at room temperature? Mercury. Understood? Next, are they conducting current? Yes. Are they conducting heat? Yes. Why? Yes, they have free electrons. What they have? Yes. Yes. No problem. Water in kitchen. They have what, beta? Free electrons. Conduction of current is there. Understood or not? Now next point. If somebody will be asking you hardness, they are quite hard. But which two elements are exactly, which are metal and they are soft? What are they? Sodium and potassium. Absolutely correct. Malleable. Malleable means you can beat into thin foil sheet. So what are they? They are malleable. Metals are malleable. You can beat them into thin sheet. Yes, malleability. Ductility means you can convert them into wire. Malleable means you can beat them into thin sheets, like aluminum sheets. Yes, in sweets and all also they are putting that silver color now. That is exactly called as malleable property. What property? Malleable. They are exactly what considered as malleable. Got it? Sonorous. Ductile means they can be bent into wire. Understood? Ductility means you can be drawn into wire, that is called as ductile. Sonorous means if you will beat them, they will be making sound. So that is called as what? Ductile. Sonorous, ductile and sonorous. Ductile means you can make wire. Because of that only metals can be carrying current. You know copper is there now. Copper, aluminium, silver. These wires are used for conduction of current and other work also. Yes or no? Because you can make them into wire. Now look here. Next one is sonorous. If you will beat, they will make sound. That is property of sonorous. Melting point and boiling point. Yes, they are generally having high melting and boiling point. Next point, what they are having is density. So they are having high density. What is the valency? Now talk about valency. Valency means the number of electrons present in the outermost orbit. Now look here, I am drawing the atomic structure and explaining it. So this is exactly the structure of the atom. This is the nucleus. Understand now? Now outermost orbit maximum, how many electrons will be there? 1, 2, 3 electrons. Sam, how many electrons will be there? 1, 2, 3 electrons means 1 electron or 2 electron or 3 electron. Then they will be considered as what? Metals. They will be considered as metals. Okay. Now electropositive character. Why metals are electropositive in nature? In simple, see, you understand one thing. You have 3 chocolates and your stomach is fully filled. You don't want to eat that chocolate. What you will do? You will give. So when you are giving, you are considered as electropositive. Are you understanding? When you give, you will be considered as electropositive. And when you will take, you will be considered as electronegative. Giving is positive. Taking is negative. Did you understood? So metals are giving. See. No. Then it will get metalloids or non-metals. Above 3, 4 metalloid content will go and then non-metals will be exactly coming. Understood or not? But 1, 2, 3 will be considered as metals. That means outermost orbit if 1 is there. Outermost orbit 2 is there. So look here. Outermost orbit how many electrons are there? 1. Outermost orbit how many electrons is there? 2. Or outermost orbit how many electrons are there? 3. Then what they are considered as? Metals. Understood? And because they are donators. They are giving the electrons. So since they are giving the electrons, what they are considered as? Electropositive. So when they will give, they are considered as electropositive. So metals are actually electropositive. Metals are what? Electropositive. So I am keeping it till here. Next class, non-metals and metalloids we will do. Okay. Bye everyone.